There we go. All right, so guys, circles.
Section 4.
Yep.
You've done this before.
Yeah, I mean, you guys should have done,
Yep. These
circumference and area of circles at some point in your
Probably several times.
in your career. Yeah, several times. I mean, it's really not hard. Now, remember, circumference, guys, is just another way of saying perimeter, but we say circumference for a circle. So, not much difference here. I mean, of perimeter. So it's just the distance around, but we call it circumference. And there's two ways to find circumference of a circle. You can go 2 times pi times the radius, or you can go diameter times pi. I think mostly diameter times pi is kind of phased out just because we focus more on the radius on everything versus 2 times the radius, or rather than diameter. I think it's confusing to have too many formulas.
Right.
And so,
even though that's really where pi comes from. You take any circle,
right.
That's what I always tell my students. We draw a tiny circle on the board and measure its distance around the circumference and measure its diameter, or we can go out to the soccer practice field and draw the biggest one we could in chalk and measure its circumference and its diameter. Either one, you divide the circumference by the diameter, that's how you get the number pi. And the number pi is a unique number.
Yeah, it is.
It's throughout history, it's just had a unique history where people have, for whatever reasons, mathematicians have spent their lifetimes trying to find pi out to as many decimal places as they can with different methodologies. Actually, the first recorded reference to pi is actually in the Bible. It's in 2 Kings talking about, and they estimate pi to be 3. So a pretty rough estimate, but it's there. And then throughout history, you see it over and over and over again. And so, you've all seen pi. 3.14 is an estimate of it. It'd be best if you stayed away from the 22/7.
Yeah.
That's not good. That's kind of an elementary school type approximation of pi. And so if you use your calculator, you have a pi key on there, and it's going to take it to 11 decimal places. And so that'd be the best, to just use your pi key on your calculator for that.
Yep. So let's look at some application here. There's 2 applications you're going to have to be ready for. One is the actual using the formula, and the other one is this arc length corollary. And so basically, if you look at the picture there, they show the red circle with the little blue piece in there, and that's meant to be that's what an arc looks like. It's an actual piece of the outside or the border of the circle that you want to look at, and that's called an arc. Okay, and what we want to do is measure the arc length. So it's kind of like, if we took a piece of string and we measured that string, and it would have a distance. Well, if you took that string and you put it around the outside of a circle, and then you laid it out straight, this is what's going to allow you to see what the actual distance of that arc is.
Yeah, if you could take like a curved tape measure and measure that's what it would be.
Right. Okay, so here's some application of it. Oops, so sorry, let me go back to this question. So it says find the circumference of a circle. Okay, and we put it when we label a circle here, guys. We always label it with the 0 or a circle with that dot in the center of it, so you're talking about a circle, not a 0 or an O or something like that. It's just kind of a way to differentiate between the two.
And we always label a circle by its center.
Yeah, exactly.
So circle A, circle B, whatever, that's the center of that circle.
So to find the circumference of the circle with the radius of 9, well, if they give me the radius, I'm going to use the 2 pi r formula. So 2 times 9 is 18, and then 18 pi, okay, like that, pi centimeters, excuse me, or if you plug it in your calculator and do 18 times pi, it'll give you an approximation of 56.55 centimeters. Now, one important thing here, guys, when we do deal with pi, okay, kind of when they just want the exact answer, you'll leave the actual pi in there, and you won't have to multiply that out. You'll just take your actual numbers, multiply them together, put them there, and then attach pi to the back end. If they want the approximation of that, now you're going to actually have to go 18 times that pi button in your calculator and get that out. And that's kind of an area where kids kind of mess up with this, and we'll get more into that as we go.
You have to get used to that. I just had somebody the other day ask me, why do we leave in answers in terms of radicals or pies or whatever? Why don't we plug them into our calculator all the time? Well, it's because you leave it as like 18 pi, because then you leave it for whoever's going to do something with that. If you were, drawing a circle out on the soccer field and it didn't have to be very accurate, you could round off to the nearest inch or foot or whatever. It really wouldn't matter. But if you're making a gear for a wristwatch, you need that to be extremely accurate. And so you'd take it out probably to the 10,000th decimal place at least. And so when we leave it as 18 pi, whoever's going to do something with that, they can take it to the accuracy that they need it. And so it's an exact answer is 18 pi.
That's a great way of looking at it. I never thought about it like that.
Yeah.
So then to use our corollary here, guys, it says find the radius if the circumference is 50 feet. Now this is really kind of an involved problem here, because we're going to have to work away everything here to get back to the radius here. Okay, so if I do that, if I have 50 equals 2 pi r, okay, now what I need to do is I want to get r by itself. Okay, so now I'm just going to work in the reverse order, so I'm going to divide out the 2 and the pi, okay, and that's going to give me 50 over 2 pi, which would potentially be 25 over pi, or we change that to 7.96 feet if we go back 2 decimal spots. Okay?
That's just finding the radius. That's what they asked you to do, is find the radius of that, if they gave you the circumference.
Yep. So we're just, it's working backwards.
Yep. Okay, so another similar example here, a car tire has a diameter of 28 inches. Okay, diameter, 28 inches. How many revolutions does the tire travel in 500 feet? Well, you kind of need to make the correlation here of what a revolution is. If you think about a tire spinning one time around, how far does that car actually travel when the tire spins one time? Well, if you think about that tire spinning, the distance that it would go as you spin that tire around would be one circumference of the tire. The length that it would travel would be one distance around the tire length. And so essentially what they're asking for here is for us to find the circumference of the tire and then see how many times that goes into the 500 feet. Okay, so if we have a 28-inch diameter here, we're going to take that diameter and multiply it by pi, because that's our formula. Diameter times pi is circumference. So our circumference of our car tire is 28 pi inches. Okay, and so we're going to take that and take the 500 feet that we're traveling and divide it. Okay, so we're going to take the 500 feet divided by the 28 pi in order to figure out how many times did that tire spin around to travel 500 feet. And so if we convert it to feet, because of the 500 is in feet and our 28 inches was in inches, so we got to be careful with dimensions here. So if we divide the 28 pi by 12 in order to get how many feet it's going to be, then we'll take the 500 and divide that, well, reducing that, the 7 pi over 3 then. We're going to take that 500 and divide it by that 7 pi over 3. Now remember, division means we flip and multiply, and so it's going to end up being 1500 divided by 7 pi. Okay, which again is a decimal approximation on your calculator, is going to come out to about 68.2. Now again, what is that measuring? The question was, how many revolutions does the tire travel in 500 feet? So the tire is going to go around 68 times approximately to travel 500 feet. Okay, and the conversion there was from inches to feet with that 28 pi divided by 12 there. Okay, so that again, we'll practice more of these as we go. The conversion factor there is a little bit that throws that problem a little bit there, but we'll talk more about that. Okay, and so here's applying what we talked about in the first slide. Find the arc length. Okay, and so what we want to do is find the measurement from G to H on that circle. Well, what I'd really like you to be able to focus on here is the fact that that's just part of the circumference. That's all it is. If we find the circumference of that entire circle and just figure out what part of the circle we have, then that's the measurement of that. You can kind of think of it almost as a segment, a curved segment,
right.
GH. So let's find the circumference of the whole circle first. Okay, and so the circumference of the whole circle is going to be 2 times 11, 2 times the radius, times pi. So that 2 pi 11 comes from 2 times the radius times pi. That's the full circumference of the circle. And then the part of the circle that we have, the piece of pi that we have over there, is 120 degrees out of the full 360. So if we take 120 divided by 360, we essentially have 1/3 of the circle here. And so that 22 pi divided by 3, because of the 1/3, is the portion of the circle that we have. And so that's the length from G to H. So 22 pi over 3 centimeters, or approximately 23.04 centimeters for that length of that arc. Okay? Is that how you typically talk about that?
Yep.
It's just part of the circumference of the circle. You just have to figure out what part. In this case, it's 1/3. If that was a 90-degree angle, it'd be 1/4. If it was whatever, you just divide it by 360, and that's how much of the circle that you have. Okay?
So now if we wanted to find the length of arc RS here, the measurement of RS, okay, so we want to go from, now be careful here, so when they have an arc label with just 2 letters like that, the direction you go here is really important, that it has to
Yeah.
be less than 180 degrees. And if you look at that circle there, okay, if we go from R to S around the top, you can clearly see that that's more than 180 degrees of the circle. So we need to go from R to S along the bottom there. And so that's just an important thing to be careful, okay? So when we go to set this up, all right, now we're given the arc length, so we're going to have to set things up a little bit different. So now we're going to be given that 44 on the left, okay? We want the measurement of RS, so that's the degrees, guys, okay? So be careful here of going from degrees and distance here. That's the other trick.
Yeah.
So that 44M, it says arc length there right on the thing. That's what's going to go in for RS, equals the degrees of RS, which we don't know yet, over 360 times 2 pi, and then the radius that we're given of 15.28. Okay, so now it's just a matter of, you know, multiplying some things, moving some things around. Okay, so we get, you know, 2 times pi times 15.28. It's going to be, you know, 30.56 pi, and then we're going to divide that 30.56 pi over to the other side.
sides, yeah.
Okay, and so now we get a proportion of 44 over 3.56 pi, but then we have that division by 360 still on the right side, so then the opposite of division is multiplication, and that's why that times by 360 is on top.
Yeah, they did
okay?
2 steps in one here.
Yeah, so they did 2 steps in one, but notice that 360 is on the bottom in the white step, and then it just bounces up to the top back in the yellow step. You know, and then you divide it by the 30.6 or 56 pi there, and then just plug that into your calculator. 44 times 360 divided by 30.56 pi. My advice to you guys is and make sure you do this when you do that division by 30.56 pi. Go 44 times 360, hit division, and then go parentheses.
Yeah.
30.56 pi, or else it's going to mess up your order of operations
Yeah.
when you go to do that. So if you didn't understand that, rewind it right now and listen to that part again.
Yeah, you got to be careful.
You got to be real careful there. And so then that's going to give you about 165 degrees. Okay? And then finally we have to find the circumference of this one. This one's kind of a little bit nifty, to where you have 76 degrees of the 360, and you have 7.5 of the entire circle. So to figure out the circumference of that, you just kind of set up a ratio, because 360 degrees is similar to the whole distance around, and then the 76 degree angle is proportional to that 7.5 whatever unit arc.
Yeah.
And so they just kind of make a proportion out of that, because you're comparing two things that are in essence the same.
Yeah.
And all you got to do is
You're finding part of the circle.
yeah, part of the circle.
circumference, so.
Yeah, so this cross multiply, and you get 35.53 units. This is kind of a tricky one. We'll talk more about that one too in class, but just kind of visualize why they can set up that ratio and think about that, and it'll make some sense.
Yeah, it's kind of back to parts of parts and
Yeah.
so on, and the whole and whole.
Yeah.
So, okay, guys.